Hello, hello. Welcome to another session of Swift Fundamentals. Today we are talking about functions. What are functions? Functions, according to the language guide, and what they do is functions are self-contained blocks of code that perform a specific task. For example, if you want to add two numbers together and you are doing that same sort of function, for lack of a better word, you could write a function called add and call that function anywhere in your code. So without further ado, let's go see what defining a function looks like. So here I could write a function. It starts with the keyword func here for function. Give it a name. So that's required here. A name is required. So I will say welcome, greeting, just like that. And the parents here, that's the parameter list, followed by a curly bracket and a closed curly bracket. So this is the basic body or basic definition of what a function is. You have the func keyword, you have the name of the function, you have what's known as the parameter list, and you have your body of the function, starts with a curly bracket, ends with a curly bracket. As it is right now, our function does not do anything as far as the body is concerned. So in here is the body of the function, right? Right now, the function doesn't do anything. There's no logic. How do you call a function? You call a function by writing out the function name. So here we have a function, it's called welcome greeting. If I run my playgrounds, welcome greeting right now does not do anything. As you see, my playgrounds is done executing and nothing got printed, nothing is happening. In my welcome greeting, I could go ahead and write print. Print here is also a function, right? Print takes arguments. It's taking a string argument or some argument. It could be a variable name, but print is also a function. In my print function, which is my parameter list here, I could put in a string. For example, I could say, welcome to functions in Swift, right? So now if I run or if I call my function on line 9, it will invoke this function, it will run the body of this function, it will execute line 6 and print welcome to functions in Swift. So if I run my code here, I'll see welcome to functions in Swift. So here we declared a function, we called the function here. So on line 4, we defined the function. On line 9, we called the function. Okay? So this is what it looks like. Here we are defining a function and we are calling the function. Next, we'll talk about function parameters and return values. As we said earlier, on line 4, there's no arguments or parameters, rather, in our function. So in that parenthesis here, again, what does a function look like? You have the func keyword, you have the function name, you have the parameter list, which is the curly, not the curly rather, but the parens. You have the function body, starts with a curly bracket, ends with a curly bracket, and we have a return type. We'll come to the return type later. And next you have the function call, example as we have down here. You could have welcome greeting. It doesn't take in any arguments. So here, this is, we call the function does not take arguments. Okay, so at the call side, in the parens, those are called arguments. In the function definition, the parens here, anything inside is called parameters. Okay, awesome. So let's go talk about function parameters and return values. So let's go ahead and define a function. We'll call that function print name. So print name, or actually we could say add last name, for example. So add last name will take in a parameter. So this is the first time we'll see a parameter here. Parameters goes inside of the parens. So here we could say function parameters, we could just say last name. All right, let's just call this add and say last name. And last name is a string. And return, the function itself returns a value. In our case, it just returns a string. So let's review this. We have our funky word, we have the name of the function, and we have our parameter list. We have a parameter name, last name, and we have not a return type, and we have the parameter type, right? So the type of this parameter accepts strings, and we have an arrow here indicates a return type. So this function takes in its input. We could say the input of this function is a string, and we could say the output is also a string, okay? Now, what does this do? Well, we called it add last name. So add last name will basically return, let's say add last name, we'll just create some fictional name. We'll just say return we'll return a message. So we'll say return your last name is whatever the user passed in as their last name. So this returns a string, okay? And now we'll go ahead and call our function. So here we'll call the add function. And what does this do? We'll say add. It returns, so we'll say return, we'll just say result here. It returns a value. So we'll say add last name. I'll just say Appleseed, like that. And now I'm going to print what my return result was and run my code. So here we'll see it prints out your last name is Appleseed, okay? So here we go, let's talk about this. So first we have our function definition, takes a string, returns a string. It returns your last name and uses string interpolation to add your last name. Our function returns a value. The value returns into our result constant, and now we could print result. Next, let's take a look at functions with multiple parameters. Here we have a function with one parameter. So now we could take a function with more parameters. One thing we could do with functions, we could call the function, I could call a function with the same name, or I could define a function with the same name. But what would make it different is the parameter list. In that case, my parameters are going to be different types and multiple parameters. So I'll say add number one is an integer, and I'll say number 2 is also an integer. So we have a function with 2 parameters, and our function returns an integer. So what I want to do here is return number 1 plus number 2. And if I go ahead and I call my function add, you see here we have 2 adds now. We have an add that takes a string and an add that takes 2 numbers or 2 integers. So I'll pass in my number, I'll pass in 5, and I'll pass in 10. And I'll just have a result 2. And I'm just going to print result 2. Print result 2 here and run my playgrounds, and here I'll see 15. So the answer of 5 plus 10 is 15. Again, I could call this function anywhere now because I have my block of code. So anywhere in my playgrounds, as long as the function is defined first here, in that case, I could call add and get my result. Next, we'll talk about functions without return values. Okay, so here we kind of did that earlier. We had a function here without a return value, right? We had welcome greeting, didn't have a return value. So here I could also write a function, again, just for more practice, without a return value. So here I could say programming, I could say popular programming language, for example. And here it doesn't take in any parameters necessarily. Or actually I could pass in a parameter, just say language and pass in a string and just print popular language is whatever the language that got passed in here. So I could just say language like that. Okay, and if I go ahead and I call popular language and pass in, of course, Swift, right? And run our code, popular language is Swift, okay? So it doesn't return values, right? It doesn't return any value. Next, we'll talk about functions with multiple return values. What does that look like? So here, I'll create a function, call it coordinate, or maybe get coordinate, okay? And this returns a tuple, multiple values. So in our case, we'll return a double and a double. Our coordinates will be doubles. So here I could just return, I'll just make up two fictional coordinates here. I'll say return 40.3 and 73.5, just like that. And now if I go ahead and create a coordinate constant and call my function get coordinate and go ahead and print coordinate here, you see our coordinate is a double, a tuple. So I could access the first coordinate, which is the lat. And if I run my code, I get 40.3. As we spoke about earlier with tuples in the earlier session, I could give it names. So here I could say latitude, for example. I could say latitude here, and I could say longitude, just like that. And here, instead of saying 0, I could say latitude. So when I run my code again, I will see that it's the same result, but it's easier to read now because here I'm just saying print coordinate latitude and just access latitude. I could print the entire tuple by just saying print coordinate. And here in the console, I'll see latitude and longitude. Again, easier to read by giving it label names. Okay, so our function could return multiple values. Next, we'll go see what functions are when we talk about implicit return and what that means. So if I have my function, let's call it multiply, just like that. Multiply takes 2 arguments, so we could call it num1, which is an int, and num2, which is also an int, and it returns an integer. So here I could simply say num1 times num2, right? So here we have one statement that gets evaluated in this function. We do not need an explicit return, right? So we do not need an explicit return here. Now in Swift, you could use what's known as implicit return. So here the compiler implicitly returns the value of num1 times num2. Let's go ahead and test this. So we could say multiply. In that case, we'll say multiply 10 times 8. And let's just get the result. We'll just call this result 3, and we'll print result 3, just like that. And here we get 80. Okay, so here we saw an implicit return. The compiler implicitly just returns the value of the statement. And this only works when you have one statement being evaluated. If you had multiple chains, like an if-else block, this would not work. You would have to explicitly have a return. Okay, so let's keep going. Next, we talk about function argument labels and parameter names. So here we're using, this is known as, well, not the argument label, but here we don't have any argument labels per se, because we're not passing in any arguments. Actually, right here, we have argument labels. So right here, we have an argument label. We have an argument label. This is the parameter name, and this is the parameter name. Again, for review, the function definition, the names here are known as parameter names. And where you call the function, the name here is known as the argument label. So if you do not want to add the argument label, you could ignore it, which we'll take a look at where we have omitting argument labels. But now this is what the argument label is. Num1, for example. So next we could say, let's write a function, call it get name. Okay, so get name, we could use a parameter name such that it is get name for person, and person is a string. So it depends on how you want to use the function, how you want to write the function. Argument names and parameter names could come in very handy. So now if I want to call, or not just handy, but easier to read for the person reading your code. So if I say get name, for example, already we see it reads better, right? So get name for somebody, right? So get name, in that case, I could say get name for person, or get first name. Let's just call it first name. Get first name for person. And here we'll just say get name, or get first name for, and some string. So here we could pass in a string. I'll just pass in Alex Paul, get first name for Alex Paul. And here we need first name, so I'll just say first name, just like that. So what does this function do? It gets a full name, and it gets the first name for this person. So in our case, we would just want to get access to the first name. So I could do let first, for example, equal to person dot, I could say components, or rather I could say make this an array, person dot, I could say split by some character, just like that. Okay, so what does this do? It takes the first name, last name, it separates the two, and now if I option click on first, it's a substring. Let's just see what that looks like. So if I print first, just like that, and I say 0, or rather name here, just call this name and call this name. For now, we're not returning anything. Let's just test this. So actually, let's just ignore. No, that's fine. Let's just return for now. Return the string here. And we'll just return, actually, let's just return name at 0. And remove that print statement for now. So return name, which is the first name, and then just print first name. Run that. And here, cannot convert or write, because this type here is a substring sequence, and we cannot convert this. So we have to fix this here. And now I could run my code again. And now I get Alex here. Okay, so let me stop this and run again. Okay, this is cleaner. So here we see we have our person string. We use the split function, which takes in some string. In that case, we want to split, we want to break up the full name Alex Paul into two for now, because we have an empty character. So what does this do? It basically breaks the string into two subsections. I'll have Alex and I have Paul, just like that. So in our case, let me just comment this out. In our case, we are accessing the first index, okay? So we have our string, we separate it by, again, we're taking a lot of assumptions here. We're assuming that we'll always get first name, last name. It will always have a space between the first name and last name. If that's the case, we could just go ahead and break it up around the space, get the first name. And again, this is an assumption we're making. We'll always have first name, last name. And in that case, we could access 0, which is the first index of that array, okay? And now we are able to return the first name and just print out first name. So here, what we just saw was function argument labels and parameters. So here, the function itself is written such that it reads better when you write it out, or when you call it, it says get first name for, and you pass in the string of the person. Okay, good. Omitting argument labels. All right, this comes in handy if you do not want to have argument labels like this. Like if we just want to pass in get first name and you just pass in the string. So what does that look like? Let's go ahead and set one up. So here we could, for example, let's write a function, call it square. What does square do? Square basically squares a number by itself. So if I call, so to omit argument labels, you use the underscore, and you still need an argument name, or parameter name rather. In our case, we'll say square num. Num is an integer, and I'll return an integer. And now I will say num times num. Again, you still need a parameter name, but I'm ignoring the argument name. What does that look like on the call side? So here, I'll call this result. I'll call this result 4. I think we're up to 4. And then I'll say square 9. Okay. First time we're seeing ignoring argument names. So here, I'm not saying square num. This is going to be a compiler error now, because right now the compiler does not see an argument label. It ignores it. So to ignore an argument label, in case we don't want to say square num like this, we just want to say square and pass in number, which is more, it's a simpler way to just write a function call, for example, in this particular case. So we just say square 9, right? So square 9 ignores the external. There's no external argument name, but there is an internal parameter label, okay? So it just returns num times num. We use an implicit return here. Just saw implicit return. We are also using it. So implicit return, just like that. Cool. So here we saw omitting argument labels. Great. Next, we'll take a look at default parameter values. What does that mean? So here we'll create a function, call it get coffee, right? And get coffee, what does it do? Well, get coffee will just say get coffee, basically get coffee basically takes in a parameter. We'll say sugar, and sugar is an int, or it could be a double, right? but for now it's an int. So get coffee, and when we call get coffee, we want to say get coffee just like that. And for sugar, we'll say 1, for example. So get sugar 1, and then I'll put a print statement here. I'll say, here's your coffee, and we'll say sugar was added. If I run that code now, what are we going to get? Well, in our case, we'll see here's your coffee, 1 sugar. 1 sugar was added. Okay, we pass in 1. If I run my code again, let's just make sure we have a better statement. So here's your coffee, 1 sugar was added, because we just passed in 1 here at the call site. But what if we want to write our function such that there's always 1 sugar, right? How can we do that? Well, we could use what's known as default parameter values. So a default parameter value, right after the type, right after the parameter type, which is an int here, you put in an equal sign and whatever the default value you want to be. So in our case, now we have a default value of 1. So if I write my function again, let's just write this function. Here, now I'm seeing 2 initializers, or rather 2 parameter lists. I'm seeing one that doesn't take in any arguments and one that takes in an argument. So the one that doesn't take in any arguments, this one will use a default parameter or default argument here. Default, we'll say here default argument, and then this is the default parameter, right? So if I run get coffee, what happens? So get coffee prints, here's your coffee, 1 sugar was added, because no sugar was passed in here. So it takes in that default 1 and it prints out the 1 here. But if we want to have sugar or more sugar as opposed to the default 1, I could pass in 3. And if I run my code again, here's your coffee, 1 sugar was added, but somebody else wanted 3 sugars. So here's your coffee, 3 sugar was added. Okay, so here we took a look at default parameter values. Okay, very handy. Next, we'll come across variatic parameters. What does that mean? In our case here, if I go ahead and I create a function, call it sum. So sum right now doesn't have any parameters, but I could pass in a parameter here, call it, actually we'll ignore this argument. So here I'll call it values. All right, the type of values is an integer. So far, so good. And then here I will say print, we'll say the sum of values is values, because right now we just have an integer, right? So if I call sum and I pass in 5, currently the sum of values is 5 because we just have one argument, 5. But if I want to keep passing in values here, like 5, 10, 2, for example, how can I get this to work? Well, I could create an array and pass in an array here, or I could also use what's known as variatic parameters. And a variatic parameter is done this way. So you have your type, which is an integer, followed by 3 dots, just like that. So now I could pass in a varied amount of arguments, and it will just keep adding it. In my case, I have to write the logic for the add-in because right now my values, it sees values as an array. So I could just say let result equal to values, which is now seen as an array of integers. I could use the reduce function. Reduce is a higher order function. We'll talk about higher order functions next time when we talk about closures. but this takes in an initial value, which is 0. We'll start adding from 0. It takes in a closure. In our case, we want to combine all the values together by adding them. So this is what it looks like. And now I will have a result, which is an integer. So it takes all the values in our array, adds them together, returns a result. So now I could just print result here and run my code again. And now I have the sum of values is 17. It added 5 plus 10 plus 2, which is 17. So here I could just keep passing numbers. I could pass in 10, right? There's no limit with the numbers I pass in here. I could just keep passing numbers. So that's known as variatic parameters. Lastly, we'll take a look at inout parameters. What does that look like? How can we use this? So here I will say change name, for example, and we'll see what inout parameters look like. So if I write a function called change name, actually, let's just do change name, and then we'll pass in a string like that, and we'll say name equal to John Appleseed. Okay, like that. Now I'll call my function change name. I'll pass in John Wayne, for example. All right, let's see what's happening here. Well, right now, we cannot assign to value name, right? Because what name is a constant. This name here, so in any of our functions like values here, all those parameter values are constants. So by default, the arguments or the parameters rather in a function is a constant. So by default, parameters in a function are constants, right? They're constants, you cannot change them, right? Cannot be changed, right? By default, this is what's happening here. So if I want to change name, a couple of ways I could do this. Well, not change name, but be able to mutate it. I could make it a var. So it's the same name, but it's a different scope here. So this is name, right? Compiler is happy, great. Cool. But I want to change this person's name here. Let's actually create a variable. So let's create a variable, call it person name, and we could do Tim Cook, like that. We'll make it let for now, and we'll pass in person name. And we want to change the person's name, we'll print person name, just like that. So far, let's go ahead and run our code. So Tim Cook, we want to change it. We want to change Tim Cook's name to John Appleseed, right? Well, on line 102, we have a constant called Tim Cook. Person name is Tim Cook. We pass person name to our function change name. It comes into our function. This name here is local. So name here is locally scoped to the change function, right? Locally scoped means this name here could only be referred within this block of code, within 96 to 101, right? Name here doesn't exist outside of the function. So that name here is locally scoped to the change function. So if I want to change name outside of the function, I could use, well, one way we could do it, we could return a new string, right? And override what name is. Or we could also use what's known as in-out parameters. What does in-out parameters look like? Well, in-out parameters allow us to change objects or change properties outside of the function. So What does that look like? You mark right before the data type, you say inout, just like that. And then now it gives us access to change this person's name outside of the function. The compiler will complain because here we have to add an ampersand to person name because now I have a reference. So right now, this name here has a reference to the name outside. And the next error, I need to change person name here to a variable. Okay, great. So now I'm able to change name. And also, I need to remove this var keyword because now I have access to directly change name. So if I run my code again, I'll see that Tim Cook has now upgraded his name to John Appleseed here. Okay, so it's very powerful. It's a very powerful keyword that allows us to change values outside of the function. So here we were able to change the name that got passed in to this function outside of the function. So this is known as inout parameters. So now name here is pointing to the name outside of the function. This is reference. This is a reference. It has a reference to the person's name outside. So things you have to do, you have to change. It cannot be a let, it cannot be a constant because you want to be able to mutate it. It has to be a variable. And also this variable needs to be prefixed with an ampersand to indicate to the compiler this is an inout parameter. Okay, so we saw some functionality today. We'll keep looking at functions and closures. We'll keep talking about other topics and functions as well. But this is an introduction into what functions provide. So just to review, we spoke about defining functions. We spoke about return values in functions. We spoke about what functions look like. We spoke about parameters. In that case, I have one parameter here. We spoke about having multiple parameters. Here we have two parameters. We spoke about functions without return values. In that case, I'm just printing out a string. We spoke about functions with multiple return values. In that case, we have a tuple getting returned. We have latitude and longitude. We could give it names. So we could access it via names here. For example, I could access longitude here. We spoke about implicit returns. So here, if I have one statement, I could simply say num1 times num2, and the compiler will implicitly return an integer because it has an integer value here. We spoke about argument labels here. To make your function more readable, you could say get first name for. So when you call the function, it looks like this. It reads easier, get first name for somebody's name. We could use functions within functions. This is a function here. Same as print is a function. We spoke about omitting argument labels. So here I'm calling square without any argument labels because I ignored it explicitly with the underscore. We spoke about default parameter values. Here, I want to get coffee. The default is 1 sugar. If I want to add more sugars, I just pass in 3. If I just want to add the default 1, I don't pass in any arguments. We spoke about variatic parameters. In that case, I have sum here, and I just want to keep passing values to sum, and it will keep adding those values as I keep passing values here. This is variatic parameter. And lastly, we spoke about inout parameters, where you want to change a value outside of the function. You mark it as an inout, meaning I have a reference to it outside of the function. Again, thank you for watching. If you like this video, please feel free to like it and subscribe to the channel. Thank you so much. See you next time when we talk about closures. Very, very important topic in Swift. Bye-bye.